Welcome. Today discussing about the moment of inertia or angular momentum and discussing today. First of all, we see that we know the mass of the body, mass of the body. How many mass of the body contained with small particles like these, small particles contained with small particles. The moment of inertia described as the small particle moment, small particle moment like this moment, distance r square take it, mass and r square take it. Mass normally called small masses, delta m r like this. Here this is in here. This is actually for the rotating body in on axis, rotating body in on axis. We say on axis, this body, small particle take delta n, delta n, delta n particle, delta n particle. Its rotating axis is here. Omega angular velocity is rotating. This is actually rotating. This is actually rotating. Angle axis to this particle's length, distance, simple law. Then normally, moment of inertia is in I. I is introduced moment of inertia. I is equal to this quantity, like the delta m r. Delta m of the mass, delta m into r square. Right. We consider all the masses of the body. All the masses of the body. What is happening? All the masses of the body will cover capital N. Capital N. Mg is equal to S M. Capital N. Then I total equal sigma delta m r square. Delta m r square means add all the particles moment of inertia. All delta m, sigma delta m we can hold capital M, then I total equal that mr square, mass into r square. This is the derived formula for the moment of inertia. Delta mr square or total we are taking IT equal mr square. Actually mass into distance square. Mass into square. What are the unit? Unit for this. What are the unit for this? What are unit for this? Right? And the down the one you can see, yeah, you can see already. Unit for this one, I unit. Unit means M mass is the kilogram into meter square. Kilogram meter square. R is a meter. So why meter? M square. That is the moment of inertia for the rotating body into on axis, this axis, omega rotating axis. In the same time, I am describing the angular momentum. Before the angular momentum, I am introducing the linear momentum. Linear momentum, we know that mass into velocity. The body travel, mass m, body travel, V or U velocity. U velocity. Then we can say linear momentum equal mu, mass into velocity, this direction. That is also vector quantity, vector direction and both magnitude included, magnitude and direction both included this quantity, mu. What is the uh, rotating body? Rotating body called, we are describing the rotating body today discussed with rotating body uh, in subject. We are called the angular momentum. Angular momentum. What is the angular momentum? Angular momentum. Angular momentum. Right? This is the describing body. This on axis, this axis, like this body, this axis rotating, like a disc, yeah, like a disc. Omega, omega, omega. Small particle accumulate here, delta m, delta m, delta m. Here to distance r, r distance, delta m, r distance, right? We know that moment of inertia, I is equal delta m r square. Previously we described it, right? Now we are taking uh, uh, moment of moment, moment of inertia, moment of inertia, this quantity. Then we are taking again moment of moment. We consider here, right? Now we take here. We know that I equal moment of inertia between I equal mr square. Total mass into this one. I total this one. I total into this one. Right? I total into this one. Mr square. Now we describe it here. Angular momentum. Angular momentum, how to describe here? Angular momentum we can describe here like this. Angular momentum we are describing here. This axis is momentum. Momentum we say. Right? This is for the angular. Now we are describing angular Angular momentum. Moment. We know that moment is equal. Moment is equal. What that? Mass into distance. Mass into distance. Normal moment, mass into distance. Delta m r. Delta m r. Now we are getting here momentum. Right? Momentum. Moment of moment. In the moment of momentum, we have to multiply by again what that? Omega, delta m r equal, we can say equal delta m r into omega, right? R into omega. Or we know that this one. Sorry, the linear velocity and this linear velocity here we say v, but v equal omega r for the previous lessons. And that v equal omega r. Therefore, delta m equal r into v is the called the moment of momentum. What the moment of momentum? Momentum take that momentum may take moments again. Moments of moments, right? Moments of moments, right? Moments of moment, delta m r v. But v equal omega. We substitute here delta m r into r omega. This is called what's that? Delta m r omega square. Omega square. Sorry, delta m r squared omega. R squared omega. What is the delta m r square? Moment of inertia. I. Previously we described. Previously I equal I omega. This I omega is called for that angular momentum. This is denoted as L. L equal I omega. I omega. This is the angular momentum. Right? From that, moment of inertia into omega. Moment of inertia into omega. We take here, right? We take here. Can you see the board downward thing? Cannot see, I think. This cannot see, no? Again, I write moment of momentum, momentum, delta m r v, right? So write this. But v equal omega, then delta m r into r omega. This is equal delta m r squared omega. Delta m r squared is the moment of inertia of the on axis. This can write I omega. I omega this will be L. Denoted in L. L equal this equation L equal I omega. It's a moment of angular momentum. This is called the angular momentum. In the rotating body, angular momentum have for the rotation described in here L equal I omega. Right? I equal I omega. So far we discussing about the inertia, moment of inertia and angular momentum. What's the moment of inertia? I equal mr square. Angular momentum L equal I omega. The unit, what the unit? Kilogram, meter square, radian per second. Right? Angular momentum, kilogram, meter square, radian per second. Why? Omega radian per second. Only omega take the radian per second. Now here, go to further. Now here we go to further. Describing the geometrical shape bodies, moment of inertia. This is the standard one. This is standard ones. Right? Moment of inertia of the bodies. Moment of inertia of the bodies. What are moment of the inertia in the bodies? We say like this first one. First one is the circular disc, radius r. Circular disc, radius r. Circular disc, radius r. Right? Moment of inertia of the geometrical shape object. Circular disc. solid circular ring. We consider solid circular rings. Solid circular disc. This circular disc. Draw the circular disc like this here. Small we have circular disc. It's rotating this axis. This is axis. Omega. Rotating about omega. This is radius is R. Right? Mass is this is M. M called the mass. Now, moment of inertia of this axis for the rotating body. Axis all the time perpendicular to the this plane. Perpendicular to the this plane. Then I equals what that? M R square. M R square. Half M R square. Mass into R square. Right? M R square. R normally taking the capital letters we are denoting in the formula. It's M R square. Now we extend to the cylindrical one, solid cylinder like this. What is happening? Solid cylinder, capital R radius, this axis, this axis, rotate. Mass M. For this one, mass M. This is also I equal half mr square. Half mr square. That is using for the rotating. If you note that here, what is the note that here? And the longitude, then the axis along the distance not independent with the moment of inertia. Right? Moment of inertia independent of the distance. The same distance coming in any length of the cylinder, any height of the cylinder, same one. Half mr square. What is the unit of this one? Unit? What are the unit? Kilogram meter square. Right? Kilogram meter square. By moment of inertia. This one. Now here we consider ring of the ring of the hollow disc. Actually, hollow disc means ring. Moment of inertia of the ring. This is the ring. Actually, ring have some thickness and height. Actually, average R we are taking it. Average R we take ring R. This is rotating this body. Rotating this axis. Omega, rotating omega axis. Mass is the ring. M. Right? Mass is the M. This one actually given circular ring. Moment of inertia of this axis equal I equal mr square. I equal mr square. Mass into R square. Average R normally taking. Now we extend to this one. Hollow circular cylinder. This is hollow cylinder. Circular cylinder. Right? Hollow circular cylinder. Average radius R. mass M. This axis, this one rotating. This axis, this one rotating, like this, rotating this one. Right? Then here also I equal mr square. Mr square. What are the changes? Mass. Here mass changed into this mass. Right? Mass only changing. Other things okay. That is the axis along the length independent with the moment of inertia. Only dependent with the only dependent with the mass. Dependent the mass. Now we are taking sphere. Sphere. Right? Now we are taking sphere. Now we are taking sphere. What type of sphere? Solid sphere. Solid sphere. NM. And solid sphere. Solid sphere. Solid sphere rotating omega. This is the R. Mass is M. Mass is M. Right? What is the quantity of this one? Right. Actually, this L is equal 205 mr square. 205 mr square. Moment of inertia I is equal for that 205 mr square. Mr square. This is the formula. Right? For the solid one. Solid sphere. And solid sphere. Ganagolaya. Right? Now we are taking the hollow sphere. Hollow sphere. Same to hollow sphere. Hollow sphere. Hollow sphere. Hollow sphere, like this here, is hollow one. Na? Inside nothing. This is the axis, rotating axis. This is rotating. We are discussing the lesson, rotating bodies all the time. Mass M, R, is the radius. I equal to over 3 mr square. 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 Right? I equal to over 3 mr square. This is the rotating one. Now, again, finally, we are coming to the torque. We know that moment. Moment, torque. Actually, moment and torque, what is the difference? What is the difference? We take the hexagonal knot, like this hexagonal knot, right? Hexagonal knot, right? We put the spanner here. Spanner. You know that mechanics using all the time nut and spanners. This is the nut, bolt or nut. It's a shape. You can take the nut in the mechanical field. This is a spanner. Spanner, right? Now we want to nut remove. Normally nut removes anti-clockwise direction. If we are using the force here, M force here, F force, right? This axis to here, distance is R. Moment is normally we are taking moment for that moment. G moment, this direction. We are starting here, put to here, rotating this direction. Moment is normally introducing G equal mr. What that? G equal mr. M into R. M into R. Right? M mass into R. mr. Right? Right? Normally this one G Another way we have means this will try to rotate, this is rotate to this direction. Right? Is the moment. What the torque? Torque is the other thing. Torque is the same like this. Some students thinking about the torque and moment is equal, actually equal for some experimental purpose, but some difference have. Torque is the initial jerk applied to the here due to happening like this. We hammer into here, right? We are hammering to here. This is the hammer. This hammer. We want to remove. We say it is very hard nut. We cannot remove. What to do? You put the hammer to hammer to nut, right? Put to the hammer, nut like this. We want to in the hand. We are pulling. It's not coming. We are using now what the hammer. Hammering. Tuck, tuck like this hammering. What the hammering? Easy to remove. When the due to the hammering, it will take the torque. Actually, it will happen in the torque, exist the torque. This is the mean the torque. Torque is the this one. F into R, same one. Is the both same. Hammering both same. F into R quantity. F into R quantity. F into R quantity. Here also F into R. Sorry. F into R. This is the moment of R, not time. We have different of them, not mass, depend, not in only the mass, force into R. Torque normally you are taking like this notation. Torque equal Fr. Torque equal Fr. Torque equal Fr. Right? Actually, torque is the moment initially accelerate and slow down again. Slow down. Moment called the torque. Right? Torque and moment actually same like that. Moment also F into R, torque also F into R. Torque used in the jerk force, initial jerk force, life force, initial force. Right? Now, torque is relation about the angular acceleration. Actually, we apply to the torque to here. This is acceleration, alpha, angular acceleration alpha. Right? And this on perpendicular to this axis, like this axis, perpendicular to this axis, right? Perpendicular to this axis, perpendicular like this. For the board plane, perpendicular axis happening, but the moment of inertia, I, all the rotating body has the moment of inertia for on axis. Then I, then torque is equal all the time I alpha. I alpha. Torque is time equal I alpha. Right? Torque is equal I alpha. Right? So far we are discussing about the angular momentum, moment of inertia, torque, phenomena. Now we formula we describe I equal mr square, moment of inertia. Right? Moment of inertia. Angular momentum L equal I omega. I omega. I omega. Right? Torque is equal I alpha. I alpha. For the rotating bodies formula. Rotating bodies formula. Right? Rotating bodies formula. You can see the board diagram. Right. Now, finish this video. Use a subscribe share with all the students and all the interesting people. Right. Now, stopping here. Thank you very much for the watching.